Module 1, Site. What is a site? Your site is the place where plants go, a garden, flower pot, window box, yard. While most people think of a site as just a plot of dirt, it really is more than that. The site includes all of the ingredients that make it unique, such as its soil and climate. Understanding the conditions that make up your site and knowing how to deal with them is crucial to successful gardening. Helping you understand these things is one goal of the Garden Tutor course. Throughout this course, we will refer to a site as that part of your property that is relevant to the project at hand. Sometimes the site will be your whole property, and sometimes it will be a particular portion of your property. And sometimes it will be an area around one plant. Hopefully, you'll discover that you use the term in a similar fashion. At times, it will be convenient for you to call the whole yard your site, and sometimes you'll refer to a flower bed as your site. How do I determine the conditions on my site? Site analysis. You will be the detective gathering data about your site to find out which garden options should work on your site. Site analysis doesn't take much work, yet it is the most important thing you can do to prepare for a garden. Module 1, Site, will take you step by step through your site analysis. In it, we discuss the major site-related constraints, and we try to give you helpful information without any fluff. Keep in mind as you learn that site analysis isn't perfect. The basic idea we present here is the more you know about your site, the better informed you as a gardener will be. And an informed gardener makes better decisions. Module 1, Lesson 1, Climate. A climate is an average range of weather conditions in a particular place. This place can be as broad as the entire planet or as small as your backyard. For our purposes, climates break down into 3 levels: regional, area, and microclimates. Regional climates are the broadest you'll need to be concerned with, e.g. the northeastern United States. Area climates are more specific, usually the area covered by your local news station. Microclimates are site-specific. Your garden site has its own microclimate, even if the site is just one plant. As you may see, there is considerable overlap between these levels. The factors that affect your regional climate are similar to those that affect your area climate, just on different scales. The average snowfall in your state probably won't be the same as the snowfall in your backyard. Regional climate. The regional climate, or at least the regional temperature range, can be determined by referring to the USDA Plant Hardiness Zone Map in the Toolbox area of the Garden Tutor site. Zones are based on average monthly minimum temperatures, so just know what zone your site is in and choose plants that grow in your zone, especially if you order plants by mail. If you purchase plants from local nurseries, chances are good they will grow in your zone, although there are exceptions. Area climate. Your area climate is the general area surrounding your site. It includes your town, city, or county. Nearby hills and valleys, large bodies of water, and large metropolitan areas can affect all manner of weather factors. It is then a more accurate measure of what will constrain your gardening decisions than the regional climate because it encompasses a much smaller area. It is important to note that area climates can be subject to other influences beyond weather, such as prevailing soil types or deep valleys that get reduced amounts of sunlight. To determine your area climate, watch local weather reports for trends and pay attention to general descriptions that people use when discussing your area. Descriptions like, "the soil in our area is very acidic," or "our weather is affected locally by the wind patterns off Lake Erie," can clue you in to the prevailing conditions in your area. You can also ask your local nursery staff or talk to your gardening friends. Microclimate. Your microclimate includes all of the conditions specific to your site, and it is your most important gardening constraint. There are many microclimatic variables, and in the rest of this module, we try to discuss the ones directly relevant to site analysis. This module contains a lot of important information, most of it basic to successful gardening. Any factor discussed in this module can affect your microclimate and hence your garden. Lesson 2, Soil. Lesson 2, Soil. Soil is the medium that plants grow in, and it consists of air, moisture, minerals, and organic matter. It also includes the microorganisms that break down organic matter to further enrich the soil. There are many varieties of soil, but they are all derived from some combination of sand, silt, and clay. The relative percentages of these minerals determine the soil texture. The soil texture diagram will show you some standard combinations. While we classify soil according to its mineral content, plants need more than sand, silt, and clay to thrive. They need air, water, and nutrients. A good soil will have and hold all of these things based on its texture and structure. Texture refers to the size and distribution of the soil particles and is most influenced by the mineral content. The texture can tell you a lot about a soil. Fine textures, common with clay soils, get compacted easily, and compacted soils don't let much air and water in. Coarse textures, common with sandy soils, let plenty of air and water in, but don't hold them well. Structure refers to the way soil particles are put together. For practical reasons, think of structure as the shape of the soil particles. The soil minerals bind with the organic matter to form aggregates of various shapes. Some shapes are ideal for holding air and moisture in the soil. Other shapes don't allow enough moisture and air. Some allow too much, and some simply don't hold them there long enough to help the plant roots. The ideal garden soil is the one that best suits the needs of your plants. Although some plants prefer more extreme soil conditions, the best soil for most plants will be one that has a loamy texture, good granular structure, and plenty of organic matter. Successful gardens depend on good soil, so the next step is to perform a few easy tests on your soil to determine what type of soil you have. While not everyone will have the ideal garden soil, you can modify your soil by adding amendments, which are simply things you add to your soil which improve its physical characteristics. Soil Texture Test, Hand Test Method. Note: this test will give you a rough approximation of your soil texture. Some soil textures are hard to determine based on feel, however. This test will let you get your hands dirty. Moisten some garden soil. Grab a small handful and squeeze it like a sponge. Knead the soil in your hands and try to roll it between your hands. Then rub some wet soil between your thumb and fingers to judge its grit. Most soils will fit one of the following descriptions. Clay soils will feel slippery or slick when rubbed between your fingers. The sticky handful will not crumble, and it can be rolled into various shapes easily. Clay loam soils feel much like clay soils, only not quite as sticky. The handful will roll into various shapes easily, but will fall apart more readily than a straight clay soil. Silty soils have the texture of the muck found on the bottom of ponds and rivers. At first, it feels pretty smooth, but when rubbed between your fingers, it has a fine, gritty feel. The handful will stay together when squeezed, but crumbles without delicate handling. Sandy loam soils feel gritty, but the handful can be worked into a clump that will stay together if handled very delicately. Sandy soils feel very gritty, and you can see the individual sand particles. The handful crumbles quickly. Since most soils are a mix of these three minerals, the texture test may not be conclusive. The simple jar test can reinforce your texture test results. Note: The jar test should be used in conjunction with the hand texture test. Neither test is conclusive, but the two together can be helpful. Jarre test. Using a garden trowel or spade, dig a small hole, about 6 inches deep, in your site. Slice a sample from the edge of the hole as if you were cutting a thin slice of cake. Cut a sliver from the top to the bottom, using your hand to hold the slice in your trowel or spade. Remove any stones, grass, etc., and put this slice in the enclosed jar. Fill the jar to the soil fill line. Add a teaspoon of low-sudsing dishwasher detergent or a rinse agent to the jar, and fill the jar with water. Cap the jar and shake the mixture vigorously for 30 seconds. Set the jar down on a level surface. Leave the jar to settle for a minimum of a few hours undisturbed. 24 hours is ideal. This will give the soil a chance to settle. Unless your soil is straight sand, silt, or clay, you should notice at least 2 distinguishable layers of soil after the mixture is settled. There may be a third pronounced layer, although usually the middle layer blends into the top and bottom layers. The bottom layer will usually be sand. It will be lighter colored than the other layers, and the individual particles should be visible. The middle layer will be silt. It tends to blend smoothly into the top and bottom layers, but should be dark colored with extremely fine particles. The top layer should be clay. It will appear as a smooth band with few, if any, visible particles. If you have trouble discerning the various layers, you may find it helps to view the jar in good light from a distance of 3 to 5 feet. In addition, we have put an extra targeting ruler on the back of the jar that is in 1/4-inch increments and will help you see a difference between the layers to zero in on a specific area of transition. Using the ruler on the Garden Tutor soil testing jar, measure the thickness of each layer and the entire sample by counting the increments on the ruler. Divide the thickness of each layer by the thickness of the entire sample. Multiply each result by 100, and you will have the rough percentages of sand, silt, and clay that comprise your soil. Match your results to the chart to find out your soil texture type. For example, if your sand layer is 1 inch thick and the entire sample is 3 inches thick, divide 1 by 3 to get 0.33. Then multiply this by 100 to get 33%. So your soil has 33% sand in it. Repeat this process for the remaining layers. If this all sounds confusing to you, don't worry. We have included more detail and a handy calculator that will help make this process easier for you in the toolbox section of the website under Soil Texture Classifications. Note: one common misconception is that if a soil is compacted, it must be clay. This is not always the case. Any soil can be compacted. Clay simply compacts much easier than other soil types. Once you have identified your soil texture, if your soil composition is out of proportion for loam, you can compensate for this by adding various soil amendments to help improve soil structure. There are 2 things to remember though. 1, you will need to add a lot of whatever you add to make a noticeable change in soil composition. And 2, improving your soil structure takes time. The process is very gradual, although the speed at which soil structure changes can be affected by the type of amendments you use. Note: while it is possible to change soil texture by adding sand, vermiculite, or clay, the material and energy involved is considerable. Further, if you do not add enough of these substances to your soil, there will be no positive effect on soil texture. In fact, adding too little sand to clay soil can actually make matters worse. The amendment of choice is good compost, aged manure, or an improved topsoil, because these are rich in organic content and very broken down already. They will bind with your existing soil faster than other amendments, and they will sustain your plants until the soil structure has been changed. You can use raw organic matter like leaves, bark, or peat moss, but it will take longer to affect the soil structure. The raw amendments must finish composting in the soil before they bind. Still, since raw organic matter takes longer to break down, its effects often last longer. Whichever type you use, keep in mind that plants will benefit from annual additions of organic matter. If your jar test reveals that you have a straight clay, silt, or sand soil, you can add up to 50% by volume of an amendment to the soil. If your soil falls into one of the other categories, as most soils will, then add up to 25% by volume of an amendment to achieve a good mix. When you are amending a bare site, work the amendments fully into the soil before tilling or otherwise turning the soil. Module 5, Prepare, provides complete details on preparing your site. If the site already has established plants, put the amendment on top of the soil and gently rake it into the surface. A precise soil blend is not needed, by the way. Just try to get it close. As we'll remind you often in this course, most plants are remarkably flexible with respect to soil texture and other variables. There are soils they definitely thrive in, but they'll at least grow in most soils. Soil horizons. For gardening purposes, we are usually concerned with the top 6 to 10 inches of soil because most plants, from a rose to a redwood, will have their feeding roots close to the surface where most of the moisture and nutrients are. Below the 6 to 10 inch layer of fertile soil are other layers called horizons. Soil horizons are bands of differing soils that change with depth. These changes can be in color, darker shades indicating more organic material, hardness, and type. Soil horizons tend to be more fertile at the surface and less fertile the deeper they go. Generally, soil horizons are a concern only if you have a drainage problem or very limited topsoil. This is common around newly constructed homes where soil has been compacted by construction equipment and a thin layer of loam was spread over it after construction. If your soil stays wet or you have standing puddles for a few days after a good rainfall, you can either modify your horizon to improve drainage or find plants that can deal with this condition. Disturbed soils occur when infertile soil horizons are mixed in with more fertile topsoil. Backhoes and bulldozers are prime soil disturbers. If you have disturbed soil, you may need to adjust and amend it to sustain healthy plants. Special soil conditions. Clay soil. If you live in the Southeast, you probably know about clay soil. It is extremely difficult to work when wet, and it is harder to work when it is dry. Try to work it when it is moist. If you want a more workable, balanced soil, add a lot, 50% by volume, of aged compost or manure. If the soil is acidic, you'll probably want to add lime as well. Eventually, the adjusting and amending will give you a soil with much better structure. Even so, drainage and surface runoff may be a problem because the soil horizons will be tightly packed. Refer to Module 5, Prepare, to learn more about specific drainage solutions. These solutions can involve using corrugated pipe drains. In thick clay, chimneys are not very effective, or swales to divert runoff. Consult with a professional if you aren't sure what to do. Desert soils. Arid climates have unique soil problems. For starters, they are often very alkaline. They can also have a hard pan called caliche. You will have to break up. Changing soil structure by adding amendments is difficult because alkali soils rapidly dissolve organic matter. Watering often leads to the accumulation of salts in the soil because they percolate to the surface, unless there is good drainage. Raised beds or container planting is recommended, although one of the best remedies is to plant things that are well suited for these conditions. This simple practice involves a type of gardening called xeriscaping. Basically, it involves using plants suited to your environment, using mulches to retain moisture, using efficient watering techniques and devices, and maintaining the proper soil conditions for your plants. One approach that can help when dealing with unique soils is to use native plants when gardening. Whenever practical, you should use native plants. They are adapted to their regions, making them suited to the adverse conditions in your area. You may find also that they require less maintenance than other plants and attract native wildlife as well. Keep in mind that native plant species are usually well adapted to a specific environment in your area, such as a woodland setting or swamp. So, if you decide to use them, learn about the plants and their specific growing conditions first. pH. pH stands for potential hydrogen, and it can tell you a lot about your soil. For your purposes, think of it as potential nutrients. pH determines which nutrients are available to plants. In fact, pH affects the microorganism activity in your soil. Soil pH determines its acidity, sourness, or alkalinity, sweetness. The lower the pH, the more acidic your soil is. The higher the pH, the more alkaline it is. A pH of 7 is neutral, neither acidic or alkaline. For gardening, most plants prefer a soil pH between 6 and 7, with 6.5 being your target soil pH. Some plants prefer more acidic, below a pH of 6, or alkaline soils, above a pH of 8. But for general gardening, all that matters is that your soil not be too acidic or alkaline unless the plants you select can tolerate these conditions. Plants are very flexible with respect to pH, so long as your site isn't near the extremes of acidity or alkalinity for the particular plants. If your soil pH is too extreme for your plants, it creates an unhealthy environment by limiting the nourishment that is available to the plants and by weakening their natural defenses against pestilence and disease. Note: this test should be performed separately from the Jarre test. The detergent used in the Jarre test can affect your pH reading, so make sure you rinse out your garden tutor testing jar before testing soil pH. Soil pH test. The pH test is a simple indicator test requiring some soil, water, the garden tutor soil testing jar, and a garden tutor pH test strip. The garden tutor pH test strips cover a pH range of 3.5 to 9 in 0.5 increments. Each pH test strip has 4 pads that change color depending on the pH of the test material. Each pad on the pH test strip covers a specific segment of the pH range. Having 4 pads helps with accuracy since a pH range of 3.5 to 9 is broad, and the color changes can be subtle and difficult to determine. The pH strips have been specifically designed and calibrated for soil testing and cover a pH range that encompasses nearly all garden soils. If you follow the subsequent steps, you should be able to determine your soil pH within a 0.5 increment. If you need pinpoint accuracy, consider sending a soil sample to a professional soil testing laboratory. You can go to the toolbox area of the Garden Tutor site under Soil Testing to learn about current options for laboratory soil testing. You will need a representative sample of your garden soil. Using a garden trowel or spade, dig a small hole, about 6 inches deep, in your site. Slice a sample from the edge of the hole as if you were cutting a thin slice of cake. Cut a sliver from the top to bottom, using your hand to hold the slice in your trowel or spade. Remove any stones, grass, etc., and put this sample in a bucket or large container. Repeat this process a few times around your garden site. Mix the soil samples thoroughly in the bucket or container and eliminate any foreign debris. Using a tablespoon, put 8 level tablespoons, or 4 ounces, of the mixed soil into a clean plastic cup or your Garden Tutor soil testing jar, and thoroughly mix with 8 level tablespoons, or 4 ounces, of water for 30 seconds. Wait 10 seconds for the soil to settle a bit, and then dip 1 pH test strip into the solution. Hold the strip in the solution for 3 seconds. Remove the pH test strip and shake it vigorously to remove any dirt on the pads and wait 1 minute for the soil solution to fully react with the pH test strip. If the pads are still obscured by the dirt after you waited the full minute, you can quickly dip the pH test strip into a cup of distilled water to rinse off excess dirt. Depending on soil pH, some or all of the color pads will change color. Match the resulting colors with the color chart that accompanied the pH test strips to determine your soil pH. This takes a bit of work, and it helps to do this in a well-lit room or by a sunny window to accurately assess the color change against the color chart. Keep in mind, after 5 minutes, the pads on the pH test strip will dry out and the colors will fade, so the pH test strips will no longer be useful and should be discarded. Note: if you find that dirt is still making it difficult to see the color pads on the pH test strip, you can use a disposable coffee filter to filter your soil-water mixture. Simply place the coffee filter over a small cup and slowly pour your soil-water mixture into the coffee filter. Once enough filtered water has accumulated in the bottom of the cup, you can remove the coffee filter and repeat the pH test in this filtered water. For more consistent results, you can purchase distilled water for the test. It is best to purchase recently manufactured distilled water just prior to testing, as it will have a near neutral pH when it is new and unopened. We have included enough indicator strips for 100 tests, so you may want to test various parts of your site individually to see if there are variations within your garden. Spring and fall tests are useful too. Adjusting soil pH. Before you can adjust your soil pH, you should know your soil type: sand, silt, clay, or loam. Your soil type can affect the quantity of pH amendment, lime or sulfur, you use. You should also be aware that it takes a lot of amendments to change pH. If you need a more acidic soil, you can use sulfur or naturally acidic organic materials, peat moss, leaves or needles from acidic plants. If you use organic material, the pH change will be very gradual. If you are in a hurry, you may opt for sulfur. It is best not to use commercial plant acidifiers containing aluminum sulfates or fertilizers containing ammonia to alter soil pH. They are best used only to maintain plants already growing in acidic soil, and misuse can ruin your soil. The best way to raise soil pH is to add lime. Lime is readily available and easy to apply. You may have a few types of lime to choose from, depending on what retailers in your area carry. Pulverized or pelletized limestone is usually a good choice. Pelletized lime can be used in a broadcast spreader. Dolomitic limestone is limestone which contains magnesium and a few other trace nutrients. You can use ground limestone, just be aware that it is a powder, and powders are harder to apply with a broadcast spreader. Hydrated limes are also available. They work quickly, but can burn plants and flesh if used incorrectly. In any case, be sure to follow the application rates and package instructions strictly. If you add too much at one time, you can harm your plants and your soil. The following charts will give you approximate application rates for lime or sulfur at rates of pounds per 100 square feet and pounds per 1,000 square feet. Just note, if the chart disagrees with the label on the product you buy, always go with the manufacturer guidelines. Adjusting soil pH with lime and sulfur is not permanent, so you'll need to recheck soil pH every year or two and make adjustments as necessary. The degree and duration of the change depends on how finely ground the amendments are, lime and sulfur. The more finely ground, e.g. pulverized, the faster they alter pH, but shorter their effects last, generally 1 to 2 years depending on your climate. Note that pelletized lime is finely ground but aggregated with a binding agent to form easy-to-spread pellets. It is best to apply lime and sulfur in the fall or early spring, so they can start working on your soil before you plant. A few general facts about soil pH. Clay soils tend to be acidic. Sandy soils tend to be alkaline. Keeping pH at the proper level for the plants in your garden will help reduce pests and diseases. Lime helps improve the structure of the soil. And finally, rather than trying to alter your soil pH with lime or sulfur, using plants suited to your soil pH can save you time and money. Nutrients. Nutrients are essential for plant growth. Of the 16 nutrients needed for healthy plant growth, 3 merit special attention. A few others called intermediate nutrients, calcium, magnesium, and sulfur, are needed only if your plant is known to lack them. They are usually supplied when you adjust your soil pH. The rest are trace nutrients, micronutrients, that are present in most soils. The common nutrients, nitrogen, N, phosphorus, P, and potassium, K, are the prevailing ingredients in most fertilizers and can be purchased in dry or liquid form. Note that dry fertilizers require fewer applications and last longer than liquid fertilizers, although liquid fertilizers produce faster results. There are many fertilizers on the market, and it is very important to understand the labeling. There should be 3 large numbers on the label. Example 5, 10, 5, corresponding to the percentages of nitrogen, phosphorus, and potassium. In most cases, you will want what is called a balanced fertilizer, which has roughly equal proportions of N, P, and K. An exception to this general rule, if a laboratory soil analysis shows your soil overwhelmingly deficient in a particular nutrient, you may want to use either a straight fertilizer with only the lacking nutrient, or a complete fertilizer that is unbalanced in favor of the deficient nutrient. Also, some plants have specific fertilizer requirements. Potatoes, for instance, will produce small tubers if they get too much nitrogen. A final note on fertilizers. They come in organic and inorganic types. Organic fertilizers usually consist of decomposed organic matter, compost, manure, fish scrap, seaweed, that finishes breaking down after you apply it, while inorganic fertilizers are usually chemically refined organic matter. Organics often have much lower concentrations of N, P, and K than inorganics. Both give plants the nutrients they need, but inorganics are more readily available to plants, especially during climatic extremes when the microorganisms that break down organic fertilizers in your soil are dormant. Over the long run, you should use either organic fertilizers or a combination of organic and inorganic fertilizers to help maintain proper nutrient balance and continually improve the quality of your soil. Organic fertilizers are much harder to overuse because they are less concentrated, and they either contain or promote beneficial organisms that help build your soil and fight harmful pests and diseases. Complete reliance on inorganic fertilizer leads to just that, complete reliance. If you don't replenish the soil's organic content, you will have to fertilize often. In general, organics improve your environment by keeping the soil fertile. Soil testing. The tests we have discussed are very useful for determining your site conditions. Still, you may want to consider having a laboratory soil analysis performed before you plant and then every few years after that. A laboratory test can give you more detail about the nutritional state of your garden, but more importantly, it can alert you to soil contamination. If you plan to grow plants for consumption or live in an area with old houses that may have leaded paint on them, we strongly recommend a laboratory soil test. To have your soil tested, refer to the toolbox area of the Garden Tutor website under Soil Testing to find labs that you can use to get your soil sample tested. Note: we do not provide the soil testing service, and we have only included the materials you need to get a soil sample to a testing lab as a convenience. Always contact the soil testing laboratory directly to determine proper payment and procedures before sending a soil sample. You will need a representative sample of your garden soil. Get samples just as you did for the jar test, but get more of them from different parts of your site. Mix the soil sample thoroughly in a clean bucket and eliminate any foreign debris. Fill out the soil sample information sticker provided in the Garden Tutor kit and affix it to the soil sample bag. This is important because often the testing agency can make specific recommendations based on the plants you want to grow in your garden. Carefully pour 1 cup of your thoroughly mixed sample into the zipper bag. Place the bag in the mailing envelope, enclose payment, and mail it. The soil testing lab will send back a report showing your soil nutrient levels along with any necessary fertilizer application rates. Module 1, Lesson 3, Sun. Adequate sunlight for plants is essential. If they don't get the sunlight they need, they simply will not grow well. There are 2 things about the sun you need to know for your site analysis: the path and amount. First, you need to know the sun's path over your property. To do this, use the enclosed compass to find east and west. The sun will rise from the east and set to the west. Once you know the sun's general path over your site, look for east to west areas that are sunny and shaded at various times of the day. Make a note of the sun exposures. The levels are full sun, part shade, and full shade. Next, you need to determine how the sun's path changes with the seasons. The sun is highest during the summer solstice, lower during the winter solstice, and between these points during the fall and spring equinoxes. The degree of change depends on your latitude. The farther north you are, the greater the shift. The closer you are to the equator, the smaller the shift. If you are very close to the equator, you don't need to read this lesson. You should spend some time determining how this southern shift will affect the amount of sun your garden receives at different times of the year. Account for seasonal shadows based on the sun shift, and determine which parts of your site get how much sunlight. Knowing these things will help you select and place plants appropriate for your microclimate. While it may seem a bit time-consuming, try to draw a rough sketch of the summer and winter shady areas based on the path of the sun. You don't need much precision. Just try to get it close. It can be a heartbreaker to invest a lot of time and money into a garden only to discover that it is full shade for half of the year. Some careful consideration to the sun and its relation to your site will help you avoid situations like this, and will help you select plants that can thrive all year. Now, having said that a lot of precision isn't necessary, it bears saying that the more you know about the sun exposures on your site, the better you can plant with success. We provide detailed instructions on how to plot the amount of sun your garden site receives at any given time of day over the course of a year. In the Garden Toolbox area of the Garden Tutor site under Sun Plotting, we provide detailed information so you can calculate sun exposures precisely, if you are so inclined. General sunlight hints. Southern exposures are best for vegetables and plants that require lots of sun. Northern exposures receive the least sun. Morning sun is usually less intense than afternoon sun, so eastern exposures receive slightly less sunlight than western exposures. Between 10 and 2 p.m., the sun is at peak intensity. Plants that need full sun may thrive if they get direct sunlight during this time. Module 1, Lesson 4, Specific Conditions. Wind. There are prevailing wind patterns and inconsistent wind patterns. Prevailing wind patterns are relatively constant. An ocean breeze is a good example. Over the course of a year, this wind pattern may remain roughly the same or change with the seasons, but it is a regular feature of your climate. If you have a particularly strong or severe prevailing wind pattern, account for it when selecting plants and their placement. Delicate plants are badly affected by strong wind, and some plants are sensitive to winter windburn, especially broadleaf evergreens. Inconsistent wind patterns occur infrequently, usually during storms. There isn't a lot you can do about the ravages of nature, but if you live in an area prone to violent storms, you may want to pay very close attention to the location of your big plants, especially the ones that can blow over and damage your life or your property. Shallow-rooted trees near a house can be a real hazard if you live in a tornado zone, for instance. Any tree limbs near a window or hanging over your house can be a source of property damage as well. Wind can either be reduced or diverted. Reducing wind requires structures that filter the wind. Trees, shrubs, and structures such as lattice, when placed properly, do this well. Thick groups of trees or shrubs with dense foliage will divert the wind rather than reduce its velocity. So will structures like buildings, fences, and walls, which are discussed in the next segment. Structure. Trees, shrubs, slopes, outcroppings, hollows, buildings, fences, eaves, and walls make up the structure on your site. Structure can affect wind, sun, soil, and temperature conditions, and all these can affect plant selection and placement. Structure can be especially relevant when it is large. Houses and large trees can have profound effects on sun and wind patterns, and in some climates can be responsible for large amounts of snow or rain shedding off the edges. As well, some trees and shrubs have very invasive root systems that can affect the soil conditions on your site by competing with new plants for moisture and nutrients. Take these structures into account when selecting and placing plants. When designing your garden site, bear in mind that what you plant may itself become a microclimate affecting structure. Small trees get bigger over time, and what was once a full sun part of your site may be full shade in 10 years. Also, your choice of plants can affect your soil. For example, years of falling pine needles can make your soil acidic, which in turn can affect any plants in the vicinity. Determining what influence structure will have on wind patterns is not easy. If applicable, notice how snow or leaf drifts form around your property. Areas where bare ground is exposed when the rest of your site has snow or leaf coverage give hints about your wind patterns. If you plan to add structures to your site, try to anticipate how they will affect your wind patterns and place plants where they won't be damaged. Otherwise, just remember to be concerned about safety if you live in a harsh, stormy climate. Trees too close to houses and power lines can be hazardous under some conditions. You can remove tree branches or whole trees if you want to get more sunlight into an area. Refer to the pruning lesson covered in Module 8 Maintain for detailed pruning instruction. When removing trees, put some thought into it and don't make hasty decisions. You can't get that graceful oak back after you've chopped it down. Caution. Unless you are a skilled arborist, you should consult with a professional tree service before removing large trees or tree limbs. Variables. Variables are factors that may or may not affect your site. This list is by no means comprehensive, but we tried to get the most important ones. Utilities. You should know whether any underground cables and pipelines run through your site before you do any digging. You can find out by calling the various utility companies involved, but the best thing to do is contact your local utility locating service. Typically, you can dial 811 on your phone and you will be connected with someone that can assist you. You can also check with your State Public Utilities Commission if you are having trouble finding the service in your area. This service should be provided free and generally only takes a few days to perform. Also, be aware that drainage pipes, low-voltage wiring, and sprinkler systems should be taken into consideration before you start digging, as these items can be close to the surface. Bear in mind that if you damage a utility, cable, or pipeline without calling such a service, you may be liable for any resulting damage. Also, if you have an overhead power line, you'll want to plan accordingly, i.e., don't plant a tree that will interfere with a power line. Shallow soil. You should test your soil depth in the areas you will be planting. If you have only a few inches of soil before you run into bedrock, you will have to either 1. Install plants that can tolerate this condition, or 2. Consider planting in raised beds. Either way, your nursery staff can recommend plants for this condition. Be aware also that many shallow soil sites have drainage or runoff problems, which you may have to solve as well. Wet sites. Too much ground moisture can suffocate many plants. If your site is very close to the water table, you may have to select plants that can tolerate a lot of moisture. Sites near ponds, streams, and swamps can be very moist throughout the year. Sometimes the water table is high even though there is no surface water nearby, and that keeps the soil very moist. Some areas are prone to seasonal moisture due to heavy rains and flooding. If you are blessed with such a site, try to determine the average affected area and select plants that can tolerate your conditions. In Module 5, Prepare, we provide details about drainage solutions you can use as well. Finally, your nursery can suggest plants that are suited to overly moist conditions. Salt. If you live near a seashore or near roads that are salted during the winter, your plants can suffer salt damage. Salt spray can burn or kill plants, especially evergreens, so be aware of the salt exposure on your site and plant accordingly. Put up barriers or use anti-desiccant spray on evergreens. Refer to Module 8 for details on anti-desiccants. Winter salt spray tends to affect areas close to the roadside. Seashore salt spray tends to affect all of your soil, so selecting plants that can tolerate higher levels of soil salinity is a good idea. Legal considerations. Before undertaking any major landscaping on your site, check for local codes that may restrict fences, walls, or plant locations. Know exactly where your property boundary is, and by all means discuss your plans with your neighbors. All of these things can help prevent a big headache after you finish your project. Animals. Deer, rabbits, woodchucks, moles, and pets can be nice to have around, but they probably want to nibble on your beautiful plants, excrete in your lawn, or dig up your bulbs. Think about how you will handle these problems when you design your garden, not afterward. Fences, repellents, repellent plants, and your ingenuity can control unwanted visitors. You may find it nice to have a garden that attracts the local wildlife. Just remember, once you invite the animals in, they will not want to leave just because you are tired of them eating your vegetables. If you want animals and try to attract them, be sure you won't change your mind later. After the local wildlife has tasted your garden, it's much harder to discourage them from coming back. Also, be cautious with all wild animals. They can bite and they can be rabid.